Hey folks, the second video for the day is on melting points and boiling points. But before that, I'm going to do a little review on hydrogen bonding that I meant to do at the end of the last video. I'm sorry about the interruption there. This one's on hydrogen bonding. So if you want a hydrogen bond, I always tell you, find a molecule that has an OH in it or an NH in it. That's your first step. Then find another molecule that has an O or an N in it. So which molecule could this one hydrogen bond to? It could hydrogen bond to that one because there's an O there, there's an O there, there's an O there, there's an N here. Okay, next thing, let's do this one more time. Find a molecule that's got an OH in it instead of an NH this time. Now you have to find another molecule that has an O or an N in it. So it could hydrogen bond to that one, that one, that one, or that one. What's the odd one out? It's this molecule right here. You need to have an O covalently bonded to an H within the molecule, and all this has is C's and H's, so it cannot hydrogen bond. Let's talk about melting point and boiling point for a minute. Melting point and boiling point occurs when you have a change of state, and the change of state occurs when you break intermolecular forces. So if we had the propane supercooled and it was a liquid and we wanted to boil it, what we've got to do is we've got to break these. Now we've got to break these intermolecular forces. Now, what we said was, this is dispersion forces because it's all carbons and hydrogens, so this is weak and easy to break. So if we just have dispersion forces, we have a low melting boiling point. The longer our carbon chain, the higher it goes. Okay, so everything is comparison here. So the longer chain will be higher. Now, another way to get higher melting and boiling points is to have stronger intermolecular forces. So if we take a look at this molecule right here, the Cl is attracted to the C. Remember, the more electronegative molecule will be, or element will be negative. The other one will be positive. So the negatives and positives attract. So this is going to have a higher boiling point than this will because these dipoles are stronger. Now, not all dipoles are created equally. From the last video, we said the electronegativity difference between oxygen and carbon was 1. Therefore, we have a stronger negative and a stronger positive. So therefore, a stronger dipole. So this molecule has a higher boiling point than this molecule does. Now, if molecules can hydrogen bond, they're going to have an even higher boiling point because this is an even stronger intermolecular force. So you've got to find an OH on one molecule and an O on the other, and we'll get hydrogen bonding. If you want to increase the boiling point of these molecules, increase either the carbon chain length or increase the amount of places where you can get hydrogen bonding going on. That will also increase the melting and boiling point. Hey, I warned you folks, you're probably going to have to watch these videos a couple of times to pick up all the points. Make sure you have pen in hand and that you're taking good notes as you go through these videos. And once again, if you don't understand a concept, please reach out and contact me.